Hello everybody, this is Stranger's Cat and welcome to codeforces round 769 division 2. The past contests have not been that well. You might have seen me losing rating. You might have seen me lose rating on a couple of contests, but let's see whether today we'll do something different or again we'll struggle on some problems and then finally lose rating again. You might be knowing by the thumbnail of the video, by the title of the video, but I don't know what will happen still, so wish me luck and let's see what happens. We have 20 seconds remaining for the contest. Let me just open my IDE. Yes. Yes. Problem A. Waiting for it to open. Wow. Recently, the students of School 179 have developed a unique algorithm which takes in a binary string as input. However, they soon found out that some substring t of s is a palindrome of length greater than 1. The algorithm will work incorrectly. Can the students somehow reorder the characters so that the algorithm would work fine? Fine. We can just sort, right? What? Can the student somehow reorder the characters of s so that the algorithm will work correctly? Okay. Mm, fine. Okay. If I have something like uh, this, it is possible to, if I have equal ones and zeros, then it is okay. If I have equal ones and zeros, like I can reorder them to be like this. This is not a palindrome. Yes, I have to keep them alternative, right? Even this is not a palindrome, this is the palindrome, right? So they have to be equal. Otherwise, you cannot, even if I have like in two zeros. Yes, so I just have to count. Is equals to 0, c plus plus, else come on, no, yes, no. uh, if they are equal, I should give, if they are equal I should give, okay, I should give, okay, first of all this, and then also like that single case, yes, no. If they are equal, the algorithm will work. Yes, if they are equal, the algorithm will work. Yes, no, should give no, equal, and it is greater than some one. if I have only one, algorithm will never work. So I should have a no. C equals to 0. We'll just give no. Print yes if it is possible to reorder s, so that no palindromes of length greater than 1. So if b is equals to c and b is equals to 1, if b is equals to 1, yes, else if b is equals to c and if b is not equal to c, if b is not equal to c, then always a palindrome will exist. So answer is no. Wait, yes. Why for the fourth case we have no? For each test case, print if it is possible to reorder the characters of s so that there are no substrings that are a palindrome of length greater than 1. Do I have a palindrome? I don't have, right? It's possible to reorder. I need to remove all palindromes, right? Can I remove all palindromes from this? Yes. So I know the string does not contain any palindromes. Possible to reorder the characters. Oh, length 3 palindromes. What am I doing? Okay. So if the length is like greater than everything is lagging. Come on. Wow. Okay, so if n, it depends on n then. Even if I keep alternatives, I will have a palindrome. What am I thinking? Yeah. And if I don't have a, it's only possible if length is less than 2. Because if I have a length of 3, I will have if I have a length of 3, I will have 1 1 1 is a palindrome, 1 1 0 is, we have a palindrome, 1 0 1 we have a palindrome. So same for 4, right? 1 0 0 0 palindrome 1 0 1 0 palindrome, 0 0 1 1 palindromes. Yes. I think this was oh my god, wow. If I have something of length 3, like come on. I can make it. I can't make it not be a palindrome. Like if I have something of length 5. The thing is that if I get if I get a string of length 2 like this, then also it might be possible, right? It is not always yes. And s of 0 is not equal to s of 1. If they're equal, then it is no. But my rank might have gone like very 6,000, 7,000, I guess. Wow, 9,300. Very good. Problem B. It has been decided. Its construction. It has been decided to build a roof over the football. Its construction will require placing n consecutive vertical pillars. The cost is equal to the maximum value of the bitwise XOR. The heights of all pairs of adjacent pillars. Okay, fine. Find a sequence with the smallest construction cost. That means I need to reorder all the values from 0 to n minus 1 in such a way that the XOR of any two adjacents is minimum. The maximum XOR is minimum. Problem B. Yes. If I have some 0, 1, 2, 3, 4 XOR, right? XOR is like if I have 0 and 1, its XOR is 1, else XOR is 0. Fine. So numbers are these numbers, right? If I go on taking the XOR, these have XOR 1, these have XOR 3, these have XOR 1, these have XOR these two will have XOR of 7, which is dangerous. We can't keep 2 to the power n minus 1 and 2 to the power n. They will be dangerous because they will give 2 to the power n plus 1 minus 1 as their XOR. So with 100, okay, can I keep, I need to match. We can think, right, from the most significant bit to the least significant bit. In this case 100, this 4 is like the only one which has this one. So even if it goes with anyone, it will have to be, this bit will be 1. So for the next bit we can see whether if someone is having 0 or not. So we can do it with 0, so that we just get a 4. Then with 0 we can always keep a, we've already got a 4, right? Now we can keep it less than 4. Yes, whatever we do is like, we will have it less than 4 only. No, it doesn't matter. Let's see for some other case. For 6, four, 5, 6, right? Yes, so we have 6, right? 0, 1, 2, 3, 4, 5, 6, right? So these threes, they should be paired up with themselves itself. 0, 1, 2, 3, 4, 5, 6, right? Yeah, so what we can do here is that, yeah, third case, n time is equals to 3. With 6 we can take 4 and not 5, because 5 will give 3 but 4 will give 2. So we can do 4. Fine, we can do 4. Then with 4 we can put 5, I guess. See, the thing is that at least once we will get something where this bit changes, right? So at that place we will have the maximum XOR more than this bit, so it is insignificant to keep the others, right? I think, yes. So we can just do like this, right? We can do 6, 5, 4, 3, 2, 1, 0, I guess. 6 and 5 have XOR, like have XOR 3. 5 and 4 will have XOR as 1. 4 and 3 have XOR as 3, right? 4 and 3 have a very dangerous XOR. Like, okay, they have an XOR of 7. They have an XOR of 7, so this is wrong. This is wrong. But we can, what we can do is like, we can keep 4, 5, 6, then 0, 1, 2, 3. maybe like this. So 4 and 5 have XOR of 1, 5 and 6 have XOR of 0, but 6 and 0 have XOR of, okay, can I put 6 with 2? Yes, can I put 6 with 2? Because when I put 6 with 2, I will only get the XOR as 4, right? And then the others do not matter. Yes, so we can just make like this. If I have like still 7 now, so I can do like the previous power of 2, like which is 4, 5, 6, 7, and then 7 minus 4 is 3. Put 3 and then just start counting with from 0, 0, 1, 2. Like we have 9, right? Let us put 11. For 11, what we can do is that we can start from 8, we can start from 8, then 9, then 10, then 11. Then 11 minus 8 is again 3, and then put 0, 1, 2, 4, 5, 6, 7, like that. Here the XOR will become 8, which is the least, which is the max. Okay, so I guess that is correct. Let's try to code that. We'll only get n as an input. How to find the previous maximum, right? If I have 7, v is equals to 1, while int v is equals to log of n divided by log of 2. Fine. Yes, so v will become v is equals to 1 v. That means, and then you just start the you start I from v and go till n minus, go till n, and then just see out all of them. Then see out v minus n minus 1 minus v, and then loop I to v. Okay, if I is not equal to n minus 1 minus v, see out I. Minus 10, minus 10. For 2 we have minus, what is this, 0 and 1? Okay. Minus 1, 0, 1. Minus 1. Wow. This is good. For n equals to 2. Okay, if n equals to 2, you can just put 0 and 1, 2, 0, 1, that is correct. 4, 0, 1, 2, 3, yep. And 9, 1, 0, I think that is correct. Let us see. Does it fail for the case when the number is itself a power of 2? Maybe yes. If I have 0, 1, 2, 3, 4, the maximum number. Okay, I think the number is like, if I have 4, so what we can do is that we just start from 4, right? And 4 minus 4 is 0. Then you just put 1, 2, 3, because 4 and 0 have XOR of 4. And these cannot produce XOR more than 4. What if I have 1, 2, 3, 4, 5, 6, 7, 8? 8. Sorry, 9. Let us see 9. Okay, we get 8, 0. Is it because we have yes, so even if I take, it is best to take 8 with 0, right? Yes, so it has been taken, and then nothing. Yeah, I think this is correct. What else can be wrong? Can we have n equals to 1? I don't think so. Yeah. For which case can it go wrong? 8, 9, 10, then 2, which will give 8. Can I do? I'm doing 8, 9, 10, and then 2, and then 3, 4, sorry, 0, 1, 3, 4, 5, 6, 7, like that, right? Yes. So these will have an XOR of 8, but what if I have like, yes, means even if I do like an XOR of number of u if I have a number x greater than 8 and a number y less than 8 greater than equal to 8, their XOR will be greater than equal to 8, right? There is something wrong in the calculation of log. What if I have like 15 or 16? Yes, 16, right? I should do log of this thing, n minus 1, right? Yes. Because because the maximum number is n minus 1, and I was assuming that to be the number n. Yes. Now will it work for all numbers? What? Yes, and then we have 15 also. Let's suppose we have 7. Okay, so but if I have like 8, I think this is correct now. 8 was already, come on. Fine, let's go to problem C now. C is the one which will help me get a rating if possible. Igor is in 11th grade. Tomorrow he will have to write an informatics test by the strictest teacher in the school. Igor knows how the test is being conducted. First of all, the teacher will give each student two positive integers a and b. Okay. After that, the student can apply any number of operations, any number of times. The following operations: either increase a by 1 or increase b by 1, or replace a with the or of a and b. To get full marks on the test, the student has to tell the teacher the minimum number of required operations to make a and b equal. Igor already knows which numbers teacher will give. Help him figure out. Fine. We'll get pair of numbers which are both and up till 10 power 6. Problem C. Problem C. Yellow is too much used. Let's use like, okay, blue. C. So in C, what they say is that we have two numbers A and B, right? Either do, what is an operation? Either do A plus plus, either do B plus plus, or do A is equal to A or B. Fine. What is an OR operation? OR operation will always increase a number or make it or keep it same. When can an OR operation make the two numbers equal? If I have some numbers 1 0 1 1, what should be the other number to make both of them equal? Okay, wherever we have a 0, the other number should also have a 0. If this is A, B should be like 0, and these can be anything. Fine. So they will, or maybe if we have A, if we have B as something like this, so A should become like this. Fine. 0 should the main thing is like the 0 should match. Fine. So one of the things is that like you just keep on increasing A until you get this condition, and then you just apply the OR. But the thing is like always A will only become A or B. So is it possible that, okay, is it possible to make A approach B? Wait, yeah, okay, we have one, yeah, we know that A and B is always greater than equal to A, and A or B is always greater than equal to B also. Fine. That means A or B is always greater than equal to the maximum of A and B. Fine. So if A was less than B earlier, then A is equal to A or B will make A is greater than B. Okay, finally, firstly a was less than b, but if we apply this operation, then a will become greater than b or equal to b. Fine. If a is greater than b, then we cannot do more OR operations to bring b closer to a, because if we do OR operation again we'll get a bigger than b. Then we have to do b plus plus and then try again some operations. Or actually b minus a is less than equal to 10 power 6, right? The thing is that if we get a pair of a comma b and we try to solve, if you can, like, we can do is that we can do this minimum number of operations, right? We can find the minimum number of as minimum of a plus 1 comma b, the answer of this, then the answer of this, and the answer of this. But the thing is that if we apply this kind of dynamic programming, the number of pairs are like 10 power 12. Number of a comma b's are 10 power 12. So this will become too much. We can't do this. But what we can do though is, like, how many submissions in C? 288. Okay, 473, fine. Yes. If I have a like this, and if I have b something like this, like that, so this is a, this is b. What we can do is, like, just increase b one by one and then try to make it equal to a. But the better thing is that can we try to make is the camera correct? Yeah, will work. So if I try to do or now, it will become the or now will become 1 1 1 1 1 1 1 1 0 1, and b will remain as 0 1 0 1 1 0 1. So a became more far than b. A went more ahead of b, which is not what else we could have done. Maybe we could have done b plus plus once, but no. Changing b any, can we change b to affect if we change b, something like this. Let's suppose we added some couple of number of operations, and we increased b, and we got this. Still the OR will become and this will be this. Still the thing is like A became A went more farther than B always. So the thing is that if A is greater than B, using OR operation will push A more farther. Fine. And eventually we'll have to reach A by adding some values, right? So I think the answer is always A minus B. But if B is greater than A, see, for the case when B is equal to A, it is just answer is 0. If B is greater than A, for example, B is this and A is just 3. Let's suppose B is this and A is this. Fine. So if we do OR now, we'll get 1 1 1 as A, and B will become 1 1 0, and then we can just increase B once. But if I increase this A once, I'll get this as B, sorry, I'll get B as 1 1 0, A as 1 0 0, and then if I do OR, then also I'll get 1 1 0 and 1 1 0 in 2 operations. Fine. Let us take some more case when A is equal to 3, B is equal to 12. Not 12. Let us take as 13. So A is equal to 1 1 and 13 is this. Eight plus 4 12 plus 1 13, right? So if we do A as OR now, can we try to do like this? Just increase it once, make it, and then make it OR directly, or increase it more once. 0 1 0 1, and we have 1 1 0 1, and again you'll get equal. Just increment it 1 1 1 1 times, and then try to see in order of A. Else what you can do is that 0 1 1 0 and 1 1 0 1. Then you just do the OR once, increase A 3 times, then do an OR. Then do OR, will become 1 1 1 1 and 1 1 0 1, and then just increase B those number of times, so that will become, yeah. So the thing is that increase A plus plus A plus plus A plus plus some number of times, then do A is equal to or is equal to B, and then do B plus plus for some amount of times. Fine, maybe this is the way to do it. For example, if I have some value, let us try to code this and check whether this is working on sample test. B. So for each value, int answer is equal to int max. How many times should I increment a before doing the OR, right? That is this loop I can do 0 times, or I can do till I can start a. Let us try to code from the breakpoint. Like I will do the OR when a is equals to a till when a is equals to b minus to b. Okay, answer is always like b minus a. Absolute of b minus a, right? Yes. Yeah. If I break at I, means yes, if I have something like this, let's suppose I have a is equal to 4, b is equal to 20. So we can break means do the OR operation. We can do the OR operation at a is equal to 4, at a equal to 5, at a equal to 6, until at a equal to 19, right? Where do we need to do? Let's suppose I need to do at 6. So the number of operations was 6 minus 4 plus 6 or 4, sorry, plus 6 or 19 minus 19 plus 1 is the operation for the OR operation. Okay, so operations is equal to b minus a 6 I minus a plus I or b minus b plus 1, and answer is equals to max of answer comma number of operations now, right? And then what we can tell is that if I had b is greater than a, this loop won't work, right? And answer will be just b minus a. So see out answer. Two 10 425. My god. Sorry, it is the minimum, right? 1331 23,707 2707. Fine. This is not b. Yeah, this is 6 minus 4, right? So basically what we did is operation, if I am at I position, I minus a already I have used in incrementing a, then one I incremented used for the OR operation, and then when a became bigger, so I or b is the new a minus b. This is the third operation. I and will fine. uh, we were seeing for the case when it is 3 comma 13, right? When it is 3, I will require 3 operations. One operation. Acha. When I just perform an OR here, I will make it 0 0. Sorry, I will make it 1 1 1 1. Yes, and then 2 more operations. Yes, this will take 3. Here it already took 1 operation here. It has already taken 1 operation and then 2 operations. Was it 2? 2, yes. Then I have got 2 operations again. Sorry, I got 3 operations again because 2 operations here and 1 operation here. Then 3 operations I came here. I can also put this optimization where if I minus a is greater than has become greater than the answer, I can break. Yes, so the answer is 2. But for which test case is it failing? One three three one. Okay, it is giving 1331, right? 132 2 comma 5. How will it run for 2 comma 5? 2 comma 5. A is equal to 0 1 0 and B is equal to 1 0 1. Answer should be 2. I can increment B also initially. If I increment B initially, what I can do is that 1 1 0 and then just take the OR. Fine. Okay, so the other thing what I can do is like try to increment B in the starting. Can I increment A and B together? Increment A and B 1 times and then they will become equal or something like that. Yeah, incrementing only A is not always possible, not always the best option. I think it is wrong. Huh. Okay, 1000 submissions, 1100 submissions on C already. Can I increment? Maybe what we can try is like increment A some couple of times, increment B some couple of times. Sorry. And then their ORs come out to be equal. It means like A plus K1 or B plus K2 is equal to B plus K2. If I have some, this as a b, if I have some big number as b and some very small number of as a, like suppose only 1, so what I can do is like I can just try to match uh, this 0 in one operation, and rest all ones will be just matched by the OR. Or maybe like if I have this as a and b is just 1, so what we can do is like increment b once. We don't need to go from b to a, we can increment b once. And then just do the OR. No, doing OR here won't work, right? The thing is that if a is 1 0 and b is 1 0 1, and separate case when a is 1 0 and b is 1 1, if I increment b, if I have a as something like this, and if I have b as something like this, yes, can I match these two? I can just do like this, and then just do the OR. We'll get it is guaranteed that the sum of b over all test cases doesn't exceed 10 power 6. So it might be like the complexity is depending on b. Yeah, because we have to literally achieve b or something bigger than b. Okay. Okay, if I like cut this part out, yes, and then find the answer when b becomes smaller than a, we can increment b to match a. That is basically uh, let us call this b as b left and this b as b right, right part of b, or maybe like the mini b. Yes, so answer can be like a minus mini b plus 1, because we have done the, because we'll have to do the or at the last, right? So if b is greater than a, instead of incrementing, we can either increment a. Acha, we have the other option like, and we have like this, right? 0 1 0 0, like that. Either we increment a to either we increment a either we increment a to match this part, right? How can this match like this? Fine, sorry, this, and then we apply the or we try to match b's part to match a, and then apply or. I think like the application of or should be the last operation. What we can do is like, we can keep this thing same and try to match this part and then apply or. Application of or is the last operation, because if even after the application of or we have to do some more operations, then it is not always the ideal thing to do, I think. Yeah, so what we have to do is that is log 2 is 7 2. Yes, so if I have A and I have B, how to find the break means these breaks. either try to make this part of A 110 001, or try to make, how can I try to make this part equal to A, the back part of A equal to this one. It is when I get something like this, like that, right? Which is obviously not correct. This whole should get converted to the one. That means, like, until the next, if I need to change B to match to A, if I want to change B to match to A, the place where I have an x0, till that place I will have to increment. Means, okay, it will automatically, I think, increment. We just have to yes, I can break here. If I break here, yes, I was saying, if I break here, either I can convert this into this or this into this. This is mini A and this is mini B. If mini A is greater than mini B, I can just increment some mini A minus mini B times, I can increment B, and then one operation more. If mini B is greater than mini A, yeah, it is greater, so I can increment A itself, right? Then also I can increment mini B minus mini A times, I can do A plus plus, and then I can increment one more operation I can require to these many operations. These many operations and then one for OR. These many operations and then one for OR. If this is A and this is B, so this is only mini B and mini A. So again, like mini B minus mini A, but I won't increment this one, I won't have this one if B is greater than A. Fine. The mini B and mini A, fine. Basically, like, find the digits in A and those many number of times, just find from B also, right? Okay, fine. Can we try to run this on some case 5 comma 8? Yeah, if I have 5 comma 8, this is 1 0 0 0, this is 0 1 0 1, this is A, this is B. So 0 1 0 1 and 1 0 0 0. Okay. Uh, okay, again, like we can convert it into 5 operations. I can do this in 5 operations, but what I can do is like directly go and convert this number into this number itself. What if I had like this and 1 1 0 0 0 like that? I could have gone, okay, I can try both ways, converting this into this, converting this into this, or going direct. Like many methods are there. Hmm. Either convert this into this case or convert this into this case. We have two options. We can do directly, we can directly start in uh, a number of times, right? We can increment a until b, until b. Maybe what we can do is that we'll start from a, increment a one by one, one at a time, and check if a mod b, if a or b is equal to b, or increment b some a number of times. If we increment b a number of times, if we increment b a number of times, at some time, yes, not always, I guess. Wait. Maybe like okay, in this case what I could have done is that increment can I try to increment b 10 power 6 times, and for each, but Even it might be possible when just increment a and b once and first increment. Yeah, maybe I had some number like this. Maybe I had some number like this. B as like that. And b plus 1 is like this. A or B and B. It is TLE. Even I don't have this much memory. 10 parsecs times 10 parsecs. Hmm. Means here what I was thinking is that maybe if I start with A and B and I need to go some I need to increment some k1 amount of times A and then do an OR. Maybe if I increment like do B plus 1 and then I will require to increment A some k2 amount of time when k2 is less than k1, where k2 becomes k1 minus 1, less than k1 minus 1. Minus 1 because I already used 1 here. If I increment B amount of times, maybe I will always pass through another place where A or B will become equal. Yeah, A or B will become equal to B. Maybe I can try to increment some B's at the start and then do OR. Basically that is it. I've already tried to increment some increment some amount of A's, right? Increment A by 1 1 1 1 1 until A reaches B, and I can also try to increment B. How to try to increment B, right? Let us see that. Okay, I have some A as, let's suppose 2, B, let's suppose I have 5. I can go in B. Can I go till 10 power 6? Always going till 10 power 6 is not good because number of test cases is 10 power 4. I can go till, if I have this, right? Maybe I can go till this one. It is the next power. Yeah. Two to the power of number of digits in B. Digits in B is equal to log B by log 2 plus 1, right? But if B is already some like this, still number of digits in B is 4. So I have to go till 5 to the power 5, right? It will start from B, go till B plus dB. Fine. I have to go till here, and let's suppose I came till some 5 plus x, and then I have a 2. Fine. Then I will have to do the OR, right? So 2 OR 5 plus x is 2 or 5 plus x is the new A. Fine. I think minus we can do. Minus 5 plus x, because then B will again have to cope up with. Eventually there will be some case when this will become 0. Directly the OR will become equal to 5 plus x, right? So that will also be covered. OP is equals to I minus B plus 1 plus, that 1 is also again for that OR operation, plus 1 plus yes, 5 plus x. 5 plus x itself is I, right? I or A, and then I'll do, yeah, 1 also, you can take it there. Fine. I have I minus B plus this OR minus I or A minus. Okay, I or A will become bigger, right? So minus I. Yes, so answer is equals to minimum of answer comma OP. And again, like if the number of operations has become greater than, if I minus b is greater than answer, I'll just break and I'll see out the answer. Okay, 23329, is this correct? Fine, 1321 Okay, I guess that is correct. Means I don't have any option. Let's try to submit this. Maybe this works. Pretest passed. Fine. Because I was getting some feeling that this will pass. With my previous experiences, I can tell that might be I'll get a fail system test, but not. But this time we had 8 test cases and 8 tests, and all 8 tests have multiple test cases. So I don't think we might get a system test fail. And secondly, okay, whatever, I would like to end the stream now. Maybe I might give solutions now or solutions like after. Okay, I think we'll end the stream now. I'll end the recording now. And thanks for watching. I think today I increased my rating finally. It was a very slow start. I missolved A and B, but suddenly finally I got C on point, and that was it. I'll see whether my rating increases or decreases finally after the system testing, but until then, bye bye.